Welcome to Module 4, Monitoring, Verification, and Record Keeping. Let's start with a question. Imagine you've just completed a full 7-step clean on a stainless steel preparation table. You used the right chemical, you scrubbed thoroughly, you hit the dwell time. The table looks spotless. Is the job done? Almost, but not quite. In a professional HACCP system, doing the job correctly is only half the story. We also need to be able to prove that we did it correctly. That's what this module is all about. We're going to look at the 3 disciplines that turn our practical cleaning work into a documented, defensible system: monitoring, verification, and record keeping. Monitoring is the real-time check we carry out on our own work as we're doing it. Think of it as asking ourselves, am I doing this right now? It's a continuous, in-process check, not something we do at the end of a shift and not something we wait for someone else to do. The goal of monitoring is to catch a problem while it's happening, so we can fix it immediately, before it has a chance to become a food safety failure. It's a proactive discipline, and it sits squarely in our hands as the people doing the cleaning. So what does monitoring actually look like on the floor? It's more than just having a look at a surface. There are several types of monitoring activities we carry out as part of our daily routine. We visually inspect a surface after cleaning to confirm that all soil is gone. We use test strips to check that our sanitizer is mixed at the correct concentration. We check water temperature during the main wash. And we use a timer to make sure the disinfectant stays wet on the surface for the full required dwell time. We also work through our master sanitation schedule, ticking off each task as it's completed. Each of these is a monitoring activity, and each one gives us real-time data on how our process is performing. Every monitoring activity we perform needs to answer 4 key questions. What am I checking? How am I checking it? How often am I checking it? And who is responsible? These aren't questions we need to figure out on the spot. Our standard operating procedures lay all of this out clearly. The SOP tells us, for example, that we check sanitizer concentration using a quad test strip at the start of every shift, and that it's the responsibility of the sanitation team member assigned to that area. When we know the answers to these 4 questions before we start, monitoring becomes a routine and reliable part of our process. Monitoring is only valuable if we act on what it tells us. When our check shows that something has gone wrong, that's called a deviation, we don't just note it and carry on. We follow a set of pre-planned steps called a corrective action. The key word here is pre-planned. We should never be guessing what to do when something goes wrong. Our training and our SOPs tell us exactly how to respond. A corrective action has 4 clear steps, and we're going to walk through each one. The first step of a corrective action is to fix the immediate problem. Stop what you're doing and correct the deviation right away. Let's say you dip a test strip into your sanitizer bucket, and the result comes back too weak. The concentration is below the required level. The immediate corrective action is straightforward. Dispose of that weak solution, and mix a fresh batch at the correct concentration. You don't continue using the weak sanitizer while you think about it. You stop, fix it, and only then carry on. Speed matters here. The sooner we correct the deviation, the less chance there is that anything is affected downstream. Once we've fixed the immediate problem, step 2 is to identify and isolate anything that may have been affected by the deviation. In our sanitizer example, if we already used that weak solution on a piece of equipment before we caught the problem, that equipment is now considered potentially compromised. It gets quarantined. Nothing goes near it for food production until it's been properly re-cleaned and sanitized. Step 3 is to ask why the deviation happened in the first place. Was the dispensing system malfunctioning? Was the chemical drum nearly empty? Was there an error in the mixing procedure? We report this to our supervisor so the root cause can be investigated and fixed. Finding the root cause is how we prevent the same problem from happening again. The fourth step of every corrective action is documentation. We record what went wrong, what we did to fix it, what was done with any affected equipment or product, and what we believe the root cause to be. We do this on a corrective action report. This record matters for two reasons. First, it's the proof that we responded appropriately, that we didn't ignore the problem. Second, it creates a history. If the same deviation keeps appearing in the same area, that pattern will show up in the records and trigger a deeper investigation. Documentation is what turns a one-off incident into useful data. Let's walk through a full monitoring and corrective action scenario so we can see how it works in practice. You're disinfecting a stainless steel table in a ready-to-eat area. Your SOP requires a bleach-based disinfectant with a 10-minute dwell time. You apply it and start your timer. At the 6-minute mark, you notice that a section of the table has already dried out. That's a deviation. The surface hasn't stayed wet for the full required contact time, which means the disinfection process has failed. Here's how we respond. First, we reapply the disinfectant to the dry area and restart the timer for the full 10 minutes. No shortcuts. Second, we inform our supervisor that there was a dwell time failure. No food goes onto that table until the corrective action is complete. Third, we work with our supervisor to understand why it dried too quickly. Maybe the ventilation in that area is too strong. If so, the long-term fix might be adjusting the airflow or switching to a disinfectant formulated to stay wet longer. And fourth, we record everything: the deviation, the corrective action, and the suspected root cause. This is the corrective action cycle working exactly as it should. Now let's talk about verification and why it's different from monitoring. This is a distinction that trips people up, so let's use a simple analogy. Imagine you're a student doing maths homework. Monitoring is you checking your own answers against the back of the book as you work through the problems. You're checking your own process in real time. Verification is the teacher marking your completed homework. The teacher is providing an independent check to confirm that your process actually produced the right results. Same work, different levels of checking. Both are necessary. To make the distinction concrete, monitoring is done by the person carrying out the task, us, and it happens in real time during the process. The question we're asking is, am I doing this right? Verification is done by someone independent, a supervisor, a quality assurance technician, or an external auditor, and it happens after the process is complete. The question they're asking is, did it actually work? Both questions matter. Monitoring keeps the process on track. Verification provides the objective proof that our efforts are producing a safe result. So what tools do we use for verification? The most common one in food facilities is an ATP meter, and it's worth understanding how it works. ATP stands for adenosine triphosphate. It's an energy molecule that's present in all living cells, including bacteria, yeast, and mold, as well as in food residues. After we've cleaned and sanitized a surface, a QA technician uses a special swab to sample it. That swab goes into a handheld meter, which produces a numerical reading in units called RLUs, relative light units. A low RLU score means the surface is clean and free of organic matter. A high RLU score means there's still something on that surface, food residue, microbial contamination, or both, and the cleaning process didn't fully succeed. It's important to have the right mindset about HACCP results. A fail result is not a punishment. It's data, and it's valuable data. If a surface we've cleaned comes back with a high RLU score, it tells us and our supervisor that something in the process needs attention. Maybe the dwell time wasn't fully met. Maybe the scrubbing wasn't vigorous enough in a hard-to-reach area. Maybe the chemical concentration was slightly off. The HACCP result points us to the weak point so we can fix it. That's exactly what a good food safety system is supposed to do: find problems and drive improvement, not catch people out. HACCP monitoring is fast and practical, but the ultimate verification tool is microbiological sampling. This is where a swab or contact plate is taken from a surface and sent to a laboratory. The lab incubates the sample to see if any microorganisms grow, and can identify specific pathogens, like Listeria or E. coli, as well as counting the total number of microorganisms present. This method gives us the most detailed and accurate picture of what's on a surface. The trade-off is time and cost. Lab results can take several days and it's an expensive process. So microbiological sampling isn't used for daily checks. It's typically used to validate that a new cleaning procedure is effective, or as part of investigating a contamination problem. It's the deepest level of evidence we have. Now we come to the third pillar of this module, and in many ways the most important one: record keeping. There's a phrase that sits at the heart of every hack system, and it's worth saying plainly: if it's not written down, it didn't happen. It doesn't matter how thoroughly we cleaned a surface. It doesn't matter how carefully we checked the chemical concentration. If there's no record, then from a legal and auditing perspective, we have no evidence that any of it occurred. Our records are the proof. They're not paperwork for the sake of paperwork. They're legal documents, and we need to treat them that way. Records serve several critical purposes. They provide the proof of control, showing that we monitored our process and that it was working correctly. They allow for traceability. If there's ever a food safety investigation, records are used to trace back exactly what happened, when, and who was responsible. They can also prove that our area was not the source of a problem. And they're required by law. The HACCP regulations and the SANS 10330 standard, the South African national standard for HACCP systems, legally require accurate records of all monitoring, corrective action, and verification activities. When a government inspector or third-party auditor visits a facility, the records are often the first thing they ask to see. They'll spend as much time reviewing the paperwork as they will walking the floor. As cleaning professionals, we'll typically be responsible for several types of records. The Master Sanitation Schedule, or MSS, is where we sign off each cleaning task as we complete it. Monitoring logs are where we record the results of our checks, the sanitizer concentration at the start of each shift, the temperature of the wash water, the dwell time we achieved. And when something goes wrong, we complete a corrective action report, documenting the deviation, the response, and the root cause. Each of these records builds a picture of the facility's hygiene performance over time. Together, they're the evidence that the food safety system is functioning. Because these are legal documents, there are specific rules we follow when completing them. These are known as good documentation practices, and every one of them matters. Be accurate, record what actually happened. Be legible, use a pen with permanent ink, either blue or black, and write clearly. Be timely, complete the record at the time you performed the task, not at the end of the shift. Filling in a morning's records at lunchtime is called backdating, and it's a form of falsifying a record. Be complete, don't leave blank spaces. If something wasn't applicable, write NA. And sign and date everything you complete. There's one more rule worth its own slide, because people get this wrong. If we make a mistake on a record, write the wrong number, tick the wrong box, we must never use correction fluid to cover it up. No Tipp-Ex, no scribbling it out until it's unreadable. The correct procedure is to draw a single line through the mistake, so the original entry is still visible, write the correct information next to it, and then add your initials and the date. That's it. This approach shows that we're being transparent and have nothing to hide. Covering up a mistake, even an innocent one, looks like falsification. A clean correction done this way is entirely professional. Some people see record keeping as the least interesting part of the job. A true professional sees it differently. Our records are the signature we put on our work. They're how we stand behind what we've done and demonstrate the discipline and care we bring to every shift. Think about what a complete, accurate, neatly completed set of records communicates to an auditor, a supervisor, or a colleague stepping in to cover our area. It says, this person knows what they're doing, they follow the process, and they can be trusted. That's the reputation of a food safety guardian. It starts on the floor and it's confirmed on the page. Let's pull the 3 pillars of this module together. Monitoring is our real-time check. We're asking, am I doing this right? As we work. When monitoring finds a problem, corrective actions are our pre-planned, 4-step response. Verification is the independent check performed by someone else using tools like ATP meters and microbiological swabs, confirming that our process actually achieved what it was supposed to. And record keeping is the thread that connects it all, the permanent, legal evidence that the system is working. None of these 3 things works without the others. A process that's monitored but not documented proves nothing. Records without monitoring are just paperwork. Verification without corrective actions has no teeth. Together, they form a complete self-reinforcing system. That's Module 4 complete. You now have the full toolkit, the principles, the hazards, the 7-step process, and the monitoring and documentation disciplines that prove it all works. In Module 5, we take everything we've built and apply it to the real layout of a food production facility. We'll look at how the cleaning approach changes depending on which zone of the facility we're working in, from the raw materials area right through to the high-care zones where ready-to-eat products are handled. This is where theory meets the floor. Let's go.